everyone. Welcome back to episode Interview with Scientist. Our guest today is Dr. Parshati Patel. Dr. Parshati graduated with a PhD in astronomy. Oh, sorry, my Parshati graduated with a PhD in astronomy and planetary science and exploration from Western University. She is an active science communicator and has actively been communicating her passion for space science and technology with students and the public for 9 plus years through various outreach activities. Today, we'll talk with Parshati about her work, career, transition, science communication, astronomy, and space science. Welcome, Parshati, and thank you for joining us today.
Thank you for having me.
Pleasure. So, can you tell us about your work prior to joining the CSA on secondment?
So I've been in, as I mentioned, in science communication field for like more than 9 years now. And before my current job, I was working at the Institute for Earth and Space Exploration at Western University,
Okay.
where I technically am still employed. Since this is a secondment, but I worked as the education outreach and communication specialist there. So basically, I was leading the education outreach program as well as any kind of like external communications, that has social media, media engagement, online website, things like that. So it's a whole breadth of tasks that I was kind of responsible for when I was at the
Okay.
institute.
Interesting. So, can you tell us about your PhD work?
Yeah, so I did my PhD from Western as well. I kind
Okay.
of stayed where I did my master's and my PhD. So for my PhD, I actually studied massive stars. So these are stars that are much more massive than our sun. And the part that I studied where they are just like forming, they're super young. So technically, we won't really call them stars because stars are something that burns, at least sun-like stars or something that burns, hydrogen in its core, makes helium, but these stars are like just before that phase. And the reason why I was really interested in kind of studying those was because we couldn't really see how the star was forming because it was surrounded by a lot of dust and gas.
Okay.
And so we couldn't really directly see what was happening to the star. And so my task kind of was to use the data that we get from these kinds of stars. And I was able to use computer models to simulate what would be like closer to the star, the disk, the star itself, like how it would be. So it was a pretty neat, 4-year thesis that I did for my PhD.
Oh, that's very interesting because I am not from physics background, so this is all new for me.
Yeah, definitely.
So, what steps did you take for your transition journey? How did you
Yeah, so my transition kind of actually started at my end of my master's. And I would say transition because it was a lot about like getting work experience. And, for me to kind of have a job right after a PhD in a field that was completely different than what I did my PhD is little, kind of shocking in many ways. We were like, oh, how do you like just transition? Like, day after your PhD or like you have a job.
Yeah.
Well, it was actually years worth of kind of, mixture of like work experience, volunteer experience, and kind of doing stuff on the side.
Okay.
So my journey actually started in at the end of my master's. So, and I say 9 plus years now is because literally 9 years ago in February, I got this email that said, they were looking for an editor for a podcast that our
Okay.
institute now was developing, and the program coordinator at that time said, we just need someone to help us kind of edit these and be on the back end side, help with like the setup and things like that. And I was like, oh, that is cool, like I can do that. you
Yes.
know and like having I did my undergrad at here in Canada as well.
Okay.
But the interesting thing was, even though I had lived here for so long, like that was 5 years by that point, I was still afraid of kind of talking in public. It took me a while to get used to the accent, try to understand what people are saying, plus at
Yes.
the same time, like saying things, making sure that people are understanding. And so I never ventured into outreach opportunities, even though I had some.
Okay.
And this opportunity I thought was cool because I wasn't the face, like I didn't have to talk to people. I could
Okay.
do stuff on my back end and still be part of outreach. And so I started there. within 6 months they needed someone who to like be paid to do that because it was just a lot of work.
Yes.
And so I ended up taking it because I thought that other portion would be little, like very small. So the other portion was to actually go into classrooms and talk about space.
Yes.
And as much as I loved, I was terrified that. So when I started that, that kind of had a cascade effect, because then we had an observatory on campus, and the director heard that I enjoyed doing the outreach that I did, and he's like, "Oh, do you want to work at the observatory?" And I was like, "Sure,
Yeah.
why not?" Right? And so for most of my PhD, I actually my TA-ship, which is teaching assistantship, was in outreach. So I was doing all kinds of different outreach. This was, doing the astronomy Olympics that happens every year. Volunteering for different on-campus science outreach initiatives, and that's kind of how I gained all my experience. I volunteered on, if I didn't have a TA-ship over the summer, things like that, I would volunteer with the observatory, and kind of get the network going of people
Yes.
learning different aspects of outreach, whether it's like programming or developing activities or developing events. And even during that time, I had quite a lot of opportunities to do like media engagement. So I just learned kind of on the job.
Okay.
That's the thing. Like, especially when you're a student, it's okay to be able to do these things, right? PhD is very, very flexible in many ways. So that is how I gained all of my experience. So when it came to looking for a job after my PhD, I didn't want to do a postdoc because that would mean I have to move,
Yes.
and I didn't want to move. Like, I'd moved from India once, and I'm like, this is like not something that I want to do again. And
Yeah.
so a year before I was going to graduate, I had a meeting with my advisory council, and I said, okay, I have 1 year from like this week, and I have to graduate. My funding ends, and here are some of the options: postdoc, go find a job in industry, or do something else, right?
Yeah.
And first, I was like, I don't want to move, so postdoc is out of the question.
Okay.
Job in industry, and I was like, as much as I code for like my PhD, it's not a thing I want to be doing 24/7 like for my job.
Okay.
Um, and so like I left with a third, and I said, okay, what do you, as my supervisors, my advisory council, you guys have seen me since my master's.
Yeah.
What do you guys think I'm good at, or I should be doing? And I think unanimously everyone was like, well, we see you in two things. We either see you as like a manager of a mission because you're good at kind of, getting people to get stuff done.
Yes.
And or you could be like, working in the field of science communication, like you do outreach, you're passionate about it, you love talking to people. And so there's those two options. And I love the first one because it's like, oh, that's super cool to be like, a project manager for like a mission. But I never participated in any of the missions that Western had. So like,
Okay.
well, there goes my zero work experience in that field, right? I mean, I did work with a lot of TAs and manage them and stuff, but it's not the same thing as a large mission with budget and all of that stuff, right? So I was like, well, second option, I guess the last option is the option that I'm going to go with. And I ended up, literally emailing everyone I knew that, hey, in a year from now, I'm going to be graduating.
Yeah.
I'm looking for something in this field. If you know anything, please let me know.
Okay.
And so during that time, there was a job opening at the institute that I was working at. And I was like, I am applying to this. I don't have to move. I'm still doing what I've done for years. So I had the work experience working in the same place at a different level, obviously, because I was a teaching assistant. But that all work experience really helped me because, I could really say, yeah, like I know how the program works because like I've been here and like I've worked in that program, though not at the level that I'm being hired at, but like I've seen it from the bottom up. So, I have a different experience in how I would change things if I were to be in that position. So I ended up, getting the job, and that's where I have been since I graduated until late last year when I got a secondment. So I'm still, I'll be back to my job later in the year. So
Okay.
yeah.
That's very exciting, and it's a really exciting journey. Your supervisors were very open and helpful. That's really good.
Yeah, I think that was really the key,
Yeah,
was that throughout my PhD they were super supportive. I know that they kept saying that make sure you're not overworking, make sure you take time for,
yeah,
relaxation and, your R&R that you need to do. But other than that, like they always encouraged me to, go and try different things, get
yes,
like outside my comfort zone.
yeah. Support is very important, and thanks to your supervisor, they really supported you.
Yeah, definitely.
So, what was your steepest learning curve during your transition?
I think there were different things. So I was still in academia. So, like I was still in the same environment where I did my PhD. So it kind of helped in a few ways that I knew people and who to get in touch with to get things done, or who to talk to if I don't know what is happening or what I need to do. Right. So that was a plus point. But there are a lot of things when you go from like a student level to like a full-time job. There are things like, you got to handle budget, like
Yes.
and things like there's all like the HR and legal aspects that you have to think about. Those were the things that I never thought about from, when I was doing volunteer opportunities, or like when I was taking, any kind of TA shift. That wasn't kind of my responsibility, right? So I think it wasn't really a learning curve on like the science communication side, though I did start learning a lot more, like, get into very many details of how science communication works, which I didn't really have. I was just observing other people and learning from them. But the other aspects of the job that you don't think about, things like I mentioned, like, budgeting, like,
Yeah.
yeah, like do the household budget. That's different than
Yes.
doing like a yearly, budget for like a program,
Yeah.
right? So all those kinds of small things were like a lot of like learning curve for me.
Yeah.
Things like management of people, it's different where you're a student, it's different when you are, in a staff position. So all of those kinds of things, that I had not thought of that would come with my job,
Okay.
were the things that were like a steep learning curve.
So, how did you manage to learn these things on the way?
I just asked a lot of questions.
Okay.
Again, it was very good. So my current bosses, like, at Western, they were super helpful because I would just walk into their office and be like, so how do I do this? Like, is this the right way of doing it? Like, this is what I'm thinking I should do in this situation. Like, would this work? Just asking people
Yeah.
and getting their opinion, people who have worked, in the field, or people who are in those kind of higher level positions.
Yeah.
I think for me, that's really how I learned, and observing other people. Like,
Yeah.
I, a lot of times I was told that, well, it wasn't in my area of people, like not my group of people that are like not in my institute, but outside there were a lot of people who were like, well, you haven't truly worked in this field. Like, I don't know, like, how would you be like, how would you take on something like that? And I always thought that, well, I can observe people. I
Yeah.
don't need to be part of that process. I can stand away from it and observe how things are working, and take the observations and into utilize those things in my programming or my planning. And I think I did a lot of that in addition to asking questions, is observing what other people are doing and how they're doing, and taking the best things of the stuff they do.
Yes.
Really, like, if I don't like certain things they do, I'll be like, yep, no, I'm not doing that.
Okay, that's good.
Yeah.
So there are a few key points that you mentioned. Asking questions is very important. Talking to people is very important. So
Yeah.
these are some of the things that I say would be the key points.
Yeah, and I think one of the things is not to be afraid to ask
Yes.
questions that you don't know. I mean, like, I kind of was, this is like, I would say my transition was because as a student, like, I was always afraid to ask things. Be like, ooh, like, what if they don't know that I don't know this, right? Right, like, that's the
Yeah.
thing. As a student, you want whoever is your audience to respect you, and be like, yeah, no, that person knows whatever they're talking about.
Yes.
As I transitioned, I was like, yeah, I don't know that. Like, but I'll
Yeah.
figure it out, like, that's not a big deal. Like, that's what
Yeah.
my job is most of the time, is to figure things out,
Yes.
and solve problems, right? So, but I became very okay with saying, yeah, I don't know, but I'll figure out how other people are doing, or what others have done, and I'll ask the right questions
Yes.
to get it done.
Uh-huh. Interesting. Thank you for sharing your journey. So let's talk about astronomy and space science. What's the
Yeah.
difference between these two?
Yeah, so it's very interesting. So a lot of people say astronomy, a lot of people say space, and it's depending who you talk to. Like for me, those are kind of synonymous because astronomy is study of like celestial objects and things like that, and space normally people think space is like everything in and around us, kind of Earth and like the whole universe. So for me, they're very synonymous. I mean, people think that in astronomy we don't count Earth as like a thing. I mean, but Earth is a planet, so people like when I studied planet formation and things like that, like we always looked at Earth and other planets in the solar system. So for me, that they both are very similar.
Yeah.
When we talk about space science, that is kind of the science side of things. There's obviously engineering, law, like there's so many different kinds of things in space that one deals with. For
Yes.
me, because my love is kind of the science aspect. I mean, I love engineering and stuff
Yes.
as well, but that's my expertise is science. So
Okay.
I love the space science aspects, like learning about the formation of the stars, planets, galaxies, things like that. But also at the same time learning about the geology of planets and the moons and things like that, asteroids, comets, all of those kinds of things. So I love the science aspect of it. So I'd say space science and technology, because as we kind of learn about these things, we're using a lot of technologies to learn about them. So things like telescopes and satellites and probes. So yeah, so I say, when I say I'm like, I talk about space science and technology, that's really what I mean. I'm not an
Okay.
engineer or like any of those.
Yes.
So I'm not an expert, but I'm happy to talk about those.
Okay. So if someone wants to go move into these fields, space science or astronomy, what courses or what should be the background and how should one proceed?
Yeah, so I'm glad you kind of asked about space science because, like I said, like if you want to go in space law or space engineering or space policy, there are like all of these, space medicine. There's so many different fields, and each of those have their own like set of path that you would likely have to take. Though the interesting thing about space is you can come in from like any direction and you can still attach it to space. For space science itself, you would definitely need, like if you're in high school, you definitely need like math and science as your background. And by science, like if you want to go into kind of studying stars and the phenomena surrounded by galaxies and stars in the universe, like cosmology, all of those require like physics and math, definitely, but also sometimes chemistry, because we have a lot of astrochemists who study
Okay.
like a lot of the chemistry in space.
Yes.
But those are kind of like the basics that you would need from high school perspective. As you kind of go into a college or like undergraduate, depending on which path you want to take. So, for example, I took the astronomy or astrophysics path. So I knew that my master's, my PhD, whatever I was going to do was going to be heavily inundated by physics and math.
Yeah.
And so, like, I was doing a lot of those and computational modeling and things like that for my degree. But if you want to go into, let's say, astrobiology or astrochemistry or geology of objects, then you need, those kind of sets. So I would say for astrobiology, take like a lot of biology, but also physics and math and chemistry, obviously. And then for chemistry, like astrochemistry, you take physics, math, and chem. And then, yeah, for geology, obviously, you need to take a lot of geology courses, earth science courses as well, and some astronomy courses, or at least planetary science courses if you want to go into geology. So, yeah, different path, even in sciences itself, that people can take.
Okay. So I'm a biologist. So how difficult will it be for me to transition into space science?
It's actually not very difficult, and there are a couple of reasons for that. So biology, depending on, again, there are like different parts in biology, which
Yes.
one you are in, but we have astrobiology, which is, just in one line, if we want to define, like looking for life in universe, that requires a lot of biology, trying to understand what kind of life here on Earth exists and how there are like extremophiles that survive in craziest places on Earth and how that could be possible places in other
Yeah.
objects in the solar system. So that's like a connection. there's other connections. So if people are more working towards like space medicine, so in pharma, or even in kind of human health aspect, or kinesiology, like those kinds of fields, people would still be able to trust it, because we try to study human body in microgravity
Yes.
with International Space Station, but we're also looking to study how humans react to like long-term missions in like zero gravity.
Yeah.
So there are lots of different aspects from biology that could be transitioned, and I know so many people who who are like doing astrobiology.
Yes.
It's like a very, very interesting field. Just that I wasn't like good at biology, so I never went that way.
Okay. So I can still move into space science. I still have
Yeah,
the option.
yeah.
Okay. So there was a recent collaboration between US and Canada, wherein Canadian or astronauts will go around the moon. Can you tell us a little bit more about it? It's very exciting.
Yeah, definitely. So NASA has this Artemis program, which is going to be sending first humans around the moon,
Yeah.
and then eventually have the first woman and the next man on the moon. And believe it or not, it's in a very short time frame. So it's happening, but we now in 2024, and so that's like 3 years. It's not that far. And so Canada was able to actually, Canada is providing the Canada Arm 3. That is going to be part of this space station that is going to go around the moon.
Mhm.
And Canada is going to be supplying a Canada Arm, but also like AI based system, because this space station is not going to be inhabited by humans entire year, so it needs to service itself, and do things that it needs to do to keep it moving. And so Canada is going to be supplying that, and so in return, we actually get to send a human
Yeah.
from Canada onto the first mission that is going to send humans around the moon. So they're just going to do like a journey around the moon and come back.
Yeah.
And so we'll have a Canadian on that particular trip, and that's going to be exciting, because it's the next big thing. Like, we haven't been to the moon in so long. This is going
Yes.
to be, and that's the step before they send humans again to land the next
And
year. So that will be in
okay.
2024.
Okay. So my next question was about why don't we land on moon, but you answered that already.
Yeah, so I think in space we do it in succession in many ways, that we test out a lot of things, and so we do things in steps. So later this year, or early next year, there's going to be a mission around the moon, but it's not going to have any humans on it. And that's kind of a testing mission. And then the next one would be when they'll send the humans, but they will just go around it, they'll not land on it. And then the next one will be when they will go and land on it. So Apollo missions also did it that way, just to test out things, to make sure things work fine.
So this might be a very off question, but I'll still ask it. How has technology changed since the first moon landing in 1969, Neil Armstrong versus now?
It has changed tremendously. You can imagine. I don't know if you have seen documentaries, but maybe some people who are watching this have.
Yes.
Their computers were gigantic. And
Yeah.
they did calculations by hand,
Yeah.
and unlike human brains were doing like calculations, and their computer on the mission, they were like in kilobytes. Like, our phones have more data than, like, it can
Yeah.
store more things, right?
Yeah.
And so it has changed drastically between now and then. Things are automated now, even for like our flights, like to the International Space Station. But there's so many things that are automated. The computer takes care of many things.
Yes.
It's kind of it's a very different technology that is going to be sent. So there are pros to it. There are so many things that humans might be able to do, much more science and other things while they're there, compared to what was done back when the first time humans went to the moon.
Okay. Interesting. So let's talk about the recent Mars landing, rover Mars landing. Can you tell us briefly about the mission that it aims to achieve?
Yeah, so the Perseverance rover is, hopefully many of you have seen the amazing landing video and the amazing picture that has been sending back. So Perseverance rover is the same size as the Curiosity rover. In many ways it's similar, but it has again that upgraded technology,
Yes.
new instruments on it. And the mission for Perseverance is to look for past life. And people are like, oh, we have said this so many times before, but what's really interesting is that it landed in Jezero crater. Now, craters are places where something has hit the ground, has excavated the area, and a lot of the stuff has gone out of the crater and landed, and you have this giant hole in the ground, as I call it sometimes. This Jezero crater had water that flowed into it. You can see it like coming in and kind of going out from the other side. And
Okay.
what's really interesting is that when that water flows in, it happens here on Earth as well. As it's going into like stagnant water, you can have like this flow of material
Yeah.
closer to where that river is kind of meeting this water, and that's called a delta. Like it's like a fan shaped area, and that area has a lot of sediments, and it would likely be a good place where we can see different layers of things, and if there was any past life,
Yeah.
this is probably the place where there would be a fossilized version of these
Okay.
things. And so Perseverance is going to be using its like top notch technology that it has to be doing that.
Yeah.
And in addition, they also have these little instruments that are going to be like tester technology. So for example, it has this tiny helicopter called Ingenuity,
Okay.
and it's going to be solar powered. It's a small one. It's
Yes.
going to rotate and try to get off of the surface. It's
Okay.
not going to be really doing any science, but it's like driving a drone on another
Okay.
right?
Yeah.
Flying a drone, I guess. But that's kind of a technology demonstration. That's what it's called in technical terms. Another one which I'm really intrigued by is that they have an instrument that is going to try and convert to, as many people may know, that Mars's atmosphere is carbon dioxide. So
Yeah.
it's a lot of carbon dioxide. And so, even though it's very thin compared to that of Earth's atmosphere, it's still filled with carbon dioxide. So, if you were to send humans, you cannot open your visor and like breathe. It's
Yeah.
not going to be good. So, what
Yes.
they're trying to do is they have an instrument that is going to try and convert carbon dioxide to oxygen. And so they're trying this to see how it works. And so for future missions, if we
Yes.
were to send humans, that could be a technology that they could be using, and they don't have to bring all the oxygen with them.
Okay.
And so yeah, it's a very very neat SUV sized rover that is like roving on Mars now.
Okay. So will it come back to Earth after its mission?
So it will stay there.
Okay.
However, what's really interesting is that Perseverance is also going to be packing a lot of material. When scientists are like, oh, this is a cool rock, we need
Yeah.
this. It's going to be packing a lot of material in these tubes that they have sent. And they will be, left on the surface. And then later in the decade, they're going to send other missions to go and grab those
Okay.
test tubes. So at some point in the next decade or so, we're going to have actual Mars samples. So
Okay.
up until now, we have only had meteorites from Mars that we know are from Mars, but now we will have actual samples from Mars. So that's pretty interesting as well.
That sounds really advanced. Collecting uh, rock samples into tubes is something that can be done automatically, is
Yeah,
something really brilliant because
yeah,
in
yeah,
labs we do it
definitely.
manually. Still.
Yep, and that's the pretty neat thing. And you're doing this at like when it's like millions of miles
Yes.
away, and you are telling the rover like you are commanding it from here, and like there's a delay of communication, so you cannot
Yes.
just say, "Hey, move 5 meters," and it moves, and then you're like. It's not, it's very delayed communication. So they basically have to put in all the program for the entire day it needs to do. And
Yeah.
then they get back the data, and then they have to start again. Right. And so it's not as interesting as driving a car here where you tell it and it will move or whatever, right? So yeah, pretty interesting.
So you just mentioned meteors. What are meteors?
Yeah, so meteors are a lot of the times people call them shooting stars. So you
Yeah.
see these streaks of light in the night sky, and when they're big, they're called fireballs.
Yeah.
And recently, at least here in Canada, there have been so
Yes.
many that have been seen. It's just been crazy. Like across Canada, people have
Yes.
been seeing. But these are basically most of the time tiny dust particles. So the
Okay.
ones that you see that just go through the atmosphere, and you're like, oh, that was something. And then by the time you say that, like it's gone. Those
Yes.
are like flashes of light, like pretty fast. Those are very, very small, almost, sand on the beach that you
Oh,
go. That's how small most of the times they are. Sometimes they're big rocks or boulders. And even sometimes asteroids. So the smaller ones, they generally burn up in the atmosphere,
mhm.
as they come in, because they are interacting with the atmosphere. The friction is,
Yes.
kind of, if they're loose, they'll break up. And those are called fireballs, because a lot of the times as it goes through, you can point at it and tell people like, oh my God, look there. And they can actually see it. So it lasts for a while.
Yeah.
And then sometimes what happens when the objects are pretty big, or they're made of material that is very hard to break,
Uh,
those times they would actually go through the atmosphere, still, get that really big flash of light. Sometimes even have sonic booms attached to them, just because they're coming in at such high speeds, and they're basically pushing the air around them, and they land. And those are called meteorites. These are, these objects that are from the solar system, very pristine in a way, because other than this interaction with the atmosphere, it's probably like roaming around for like millions of
yes.
years around the
Yes.
sun doing nothing, right? Scientists absolutely love having those, because they give us the material that we don't need to go out and get it. It just comes to us. And we have had meteorites from Mars. Sometimes sometime in the past, there would have been, an impact on Mars, and it would have shelled out a lot of material, and it ended up on Earth.
Oh,
Same, we have like a lot from the moon as well. As you can imagine, the impacts would also generate a lot of, material that would likely end up on Earth as well, and from other places in the solar system as well. But, you know, most of them are like part of asteroids.
okay. So what are comets then? What is the difference between meteors and comets? And do
Yeah, so
comets have tails?
yeah, so very interesting. Yeah, so meteoroids, so they're called meteoroids before they enter the Earth's atmosphere. Then they're called meteors, and if they land, they're called meteorite. So meteoroids are smaller ones. Asteroids are obviously bigger objects, so like kilometer size or anything bigger than that. And then, I mean, few hundred meters to anything
Yeah.
bigger than 1 kilometer. But then those are mostly made of rock. So like, very much like what you would find rocks in your backyard. But what's really interesting is comets are kind of mix of the rock, but in a mostly dust form.
Okay.
Could be in terms of boulders as well, but also ice.
Yes.
So in the past we have actually sent satellites and probes to these lovely comets, and we have seen that it has like boulders, like maybe
Yeah.
house-sized boulders sometimes. But because it's made of ice, as it comes close to the sun, what happens is, because of sun's atmosphere and all the particles, it starts basically evaporating. And
Yeah.
so you get these lovely tail from that ice, but as it melts, you also have dust that is being um, shoved off of the surface at this point, and that forms a different tail. So you see two tails when it's close to the sun, but as it goes back out, it just becomes dormant, because now it's cold,
Uh,
doesn't burn anything. And so in the outer solar system, you get a lot of these icy, or a lot of people like to say that's a dirty snowball, because that's really what they look like. They're
yeah.
like, dark in color, but have a lot of ice in them. And so they're very interesting objects. Like last year, here in Canada, at least, a lot of people were able to see the comet Neowise, and that was an amazing view.
Yes.
Especially through cameras. Not probably as good for your eyes, just because it required a lot of time to get adjusted, but spectacular two tails people were able to see. And in the past, there have been amazing, like Halley's Comet, which is visible by naked eye. You don't even need to drive anywhere.
Yeah.
In the 90s, though, I didn't see it, but I was very young. But they are very spectacular objects.
Interesting. So let's talk about the night sky. We see a lot of patterns. So how do we identify these patterns? Someone says, I identified the zodiac, but I have never been able to identify anything.
Yeah, so it's very interesting that I think a lot of people don't realize that night sky was probably kind of the first kind of science that humans did,
Yeah.
because you can imagine if there was no electricity or anything like that, humans are really doing two things. In the daytime, they're seeing the sun, sometimes the moon as well, and then in the nighttime, they're seeing all of these stars. And obviously the skies would have been much more darker than what we see in the cities because of the light pollution. Now we don't really see many things, but back in the day, they associated a lot of these stars,
Uh-huh.
that would, a lot of these constellations, they are periodic in a way that, some rise in the winter, some are summer constellations. And so they associated that with the seasons.
Okay.
And to keep that knowledge going, if you look at a certain thing and you see a certain shape, it's much easier to remember that and talk about it to
Yes.
and tell other people about it if you have a story kind of associated. There's a whole lot of storytelling
Mhm.
aspect to a lot of these constellations, and in many cultures too. I mean, in Indian culture there is, in indigenous culture there is. How they associate a lot of these patterns that they see in the sky to a lot of the things that they do,
Yes.
in their daily lives in many ways. And so because there were so many different cultures had different
Yes.
ones, and there are like so many of them, the International Astronomical Union said, there is 88 constellations that we can recognize and see, give them a name, have kind of the patterns displayed where you can actually go to the IAU site and see each of them and how they're connected and what kind of shape or pattern they form, and their names as well. It's just an easier way for us to kind of know what constellations are in the southern hemisphere,
Okay.
even though we're not there, and
Yeah.
use that to associate that with the movement of the stars, the movement of the planets,
Yes.
and a lot of aspect on how to know. A lot of different people are like, you may have heard in the last couple of days that Mars was close to Pleiades. So that's, a constellation that's very well known. And so it's a way to say, oh, like, look at the sky where there's Pleiades, you will see Mars. And so there are multiple different reasons why people use constellations, but, from kind of our perspective is looking at the night sky and using them to look at objects.
Okay. So you mentioned something about light pollution. Can you tell us how do we combat light pollution?
Yeah, there is a lot. A
Okay.
lot of light pollution in the cities. Even when you go further, it's very hard for people to realize even having a light on, outside your house
Yes.
can, for, people like kilometers away, can actually detect that. And like, we have powerful lights that we don't realize how much it hurts people who are looking at the night sky. And so one real good way is to start using these LED lights. The old halogen bulbs are like bad. They're
Yes.
bad for electricity. They're bad for the night sky. Starting to use something that is much more dimmer is also very useful. But the most interesting thing is, you may have seen that when you have, the street lamps,
Yes.
they're facing upwards. If you face them downwards, I mean, that's not kind of in our control, but we can
Yeah.
always ask our government to do that. If they are downwards, that, limits the amount of light you are letting into the sky. So that is something that's very helpful. If you
Okay.
have lights outside your house and things like that, you can always just move it, bring one that's like facing downwards and put in a LED. That is very helpful as well.
Okay.
One of the things we astronomers like to do, or I guess astrophotographers like to do when they go out, is actually use a red light, because to your eyes, that's very mellow. You may have seen on your cell phones, they now have a nighttime version,
Yeah.
which is much redder than what you see in the daytime. That actually hurts your eyes less. It gets your eyes adapted to darkness more easily. And so, using red lights, that's what we use all the time. Our headlights are always red,
Yeah.
to make sure you're not bombarding anyone with light. So if you're able to change your lights to red, in your houses, around your neighborhood, that is also very good for light pollution.
Okay. Thank you for the advice.
No
So,
worries.
what do you enjoy outside of work? What are your hobbies?
uh, so a lot of my hobbies are related to space.
Uh, One of them is photography.
Yes, yeah, I love taking night sky photos. It was my thing when I was in PhD. That was my, you know, thing outside my outreach and my PhD thesis. But then I kind of lost touch because I didn't really have much time and all of that for a couple of years. But my pandemic kind of brought it back. It's like, yay, now I have time and I can do other things. And so night sky photography is definitely one. The other thing I've kind of picked back up in, which I was doing for a few years on and off, was painting. So I don't know if you can see it right there. That's my
Yes.
Mars painting for a couple of weeks
Yeah.
ago. That's like
Yeah.
my Earth moonshine, or I guess Earthshine painting from a couple. Actually, that was last year. So yeah, I've started doing painting a lot as well. I've also I enjoy cooking. I'm Gujarati, like I'm a foodie
Yes.
by like birth. So absolutely, like I cook because I absolutely love to eat
Yeah.
very many different Indian cuisines, and I try and recreate that because London doesn't have as much diversity of restaurants. So I cook at home.
Okay. So can you suggest some good equipment for night sky photography?
Yeah. So do you mean like by instruments or just
Yeah,
like in
instrument,
general?
cameras, phones, lenses.
Yeah. So cameras, you mentioned like really cool. So like cell phone is a great starter kit. Like believe it or not, cell phones these days are amazing. I have iPhone 11. It's not that good, but it can do a little bit of long exposure photography, which means that you can keep the camera open for longer than 1 second, and you can collect more light. And so Google Pixel 4 is an amazing cell phone. If you were to buy one and if you want to go for an astrophotography one, Google Pixel 4 is great. I have a friend who does 3 minute exposure. So he keeps the camera open for 3 minutes and he gets galaxy, the Milky Way galaxy, as good as what my DSLR from 8 years ago does. So it's an amazing tool. It's very easy. You just need a small tripod and you just need, to stabilize it because you don't want to touch it as it's moving. And you just leave it as long exposure and, you get a night sky. Amazing photo.
Okay.
Um, in terms of like an actual like DSLR and cameras like that, even the most basic cameras these days that you can buy where you can change the lens and change the amount of light that you can keep the amount of light you can get, but keeping the shutter open for a long time.
Yeah.
Those are also good ones. And so I started in 2012 or 13 with a Canon T3i. So at that time it was super expensive. Right now you can actually get a T7i, which is much more advanced version of that camera for like $550.
Okay.
And so having that and grabbing a tripod is pretty important. You don't want to touch it while it's doing this 30-40 second exposure. And so like, my suggestion would be start with like something like super basic like that, if it's possible. If not, if you have a cell phone, there are lots of apps that does it for you as well. A lot of them are paid apps, but it's still a good starting point. And then you move on to more expensive things. This was a conversation I was having earlier this week where I was saying, I just bought a new camera and getting into astrophotography is like super expensive.
Yeah.
Once you start getting into it more detail. So I bought a tracker last year, which is basically because our Earth moves,
Yes.
obviously, the night sky changes. A lot of people don't realize that when you see the particular constellation here, after a few hours, like it will move. And I like to catch the Milky Way because I just think it's just mind blowing.
Okay.
And so to be able to get amazing shots, just more than as it moves, we just have to keep a track of it as it goes. And I still can take a picture of the Milky Way and get as much light as I can, sometimes even for a couple of hours. There's such details from it. And so I bought this tracker that allows me to track that particular route that Milky Way is taking. And that was expensive. And then I decided that I need to upgrade my camera because it was 8 years old. And obviously cameras these days are changing much faster than what it was, 10 years ago. And so I upgraded that. And now I realized that my old tripod doesn't work with my tracker. So now I need a new tripod. it's an expensive hobby if you do
Yes.
get in.
So,
But it's also probably the most satisfying hobby is because I get to go out in the night sky. This is just mostly over the summer because I'm still not used to the cold in Canada.
okay.
But but the really interesting thing is like once I set up my camera and just like have it go because a lot of these cameras can do things automatically,
Yes.
don't really need to touch it. I'm literally observing the night sky. Like I'm sitting there, I'm just watching, yeah, stars, and I get to go to these darker skies that are, you know, so much more darker than the cities that you can sometimes see even Andromeda galaxy with your naked eye. You don't need a telescope for that.
Yeah.
And like it's just mind blowing what you can see. And so I get to enjoy both the aspects. If you're interested in night sky observing,
Yes.
grabbing, like starting with like a cheap DSLR and a tripod, even with the most basic lens that comes with the DSLR, you can do so much. And I actually did it for years before I bought my next lens, which again, it's just a black hole of money if you want to put in there.
Yes.
But it's one of my favorite hobbies.
Thank you very much, Parshati, for sharing your journey and about space science today. I really enjoyed talking to you. Thank you very much.
Thank you so much for having me. I had a great time.